The concept of time travel has captivated humanity for centuries. It's a notion that transcends cultures and epochs, weaving its way into the very fabric of our collective consciousness. From ancient myths to modern science fiction, the idea of journeying through time has sparked our imaginations. Stories of gods and heroes traversing time can be found in the mythologies of ancient civilizations, while contemporary literature and cinema continue to explore the endless possibilities of time travel. We yearn to witness pivotal moments in history, right wrongs, or catch a glimpse of the future. The desire to alter the past or foresee what lies ahead speaks to our deepest hopes and fears, our regrets and aspirations. Imagine standing alongside dinosaurs, traveling with Alexander the Great, or witnessing the birth of the universe. These scenarios, though fantastical, allow us to ponder the vastness of time and our place within it. The allure of time travel lies in its power. It offers a sense of control over the uncontrollable, a chance to rewrite our stories or explore uncharted territories. It allows us to break free from the linear constraints of time. The idea that we could move backward or forward through time challenges our understanding of reality and opens up a realm of infinite possibilities. We could explore the past and potentially influence the future. The implications of such power are profound, touching on everything from historical accuracy to the butterfly effect. But time travel is more than just a fun thought experiment. It's a concept that invites us to question the nature of time itself, to explore the boundaries of science and the depths of human imagination. It raises profound scientific, philosophical and ethical questions. What are the consequences of altering the past? Can we change our destiny, or is the future already written? These questions challenge our understanding of free will, causality, and the very nature of existence. Join me as we embark on a journey through time. Together we will explore the myriad facets of this captivating concept, from its scientific underpinnings to its philosophical implications. We will explore the science behind this captivating concept. From Einstein's theory of relativity to the latest advancements in quantum mechanics, we will delve into the cutting-edge research that brings us closer to understanding the possibility of time travel. We will delve into the philosophical and ethical dilemmas it presents. What responsibilities come with the power to alter time? How do we navigate the moral complexities of changing history or predicting the future? And we will examine how time travel has been portrayed in popular culture. From H.G. Wells' The Time Machine to blockbuster movies like Back to the Future, we will see how these stories reflect our hopes, fears and dreams about time travel. Fasten your seatbelts. Our adventure is about to begin. Prepare to journey through the annals of time, exploring the past, present and future in ways you've never imagined. To understand time travel, we must first grasp the nature of time itself. Time, as we perceive it, is a continuous progression of events from the past through the present and into the future. It is an ever-flowing river that we are all swept along by, seemingly at the same pace. Our everyday experience suggests that time flows at a constant rate. We wake up, go about our day and sleep, all within a 24-hour cycle that repeats itself. This regularity gives us a sense of stability and predictability. 1 second feels the same for everyone, everywhere. Whether you're in New York, Tokyo, or a remote village, the ticking of a clock is a universal experience. This uniformity is deeply ingrained in our understanding of the world. However, Albert Einstein revolutionized our understanding of time with his theory of relativity. He proposed that time is not a fixed entity, but is intertwined with the fabric of space itself, forming what we now call the space-time continuum.
Einstein showed that time is not absolute. It can stretch and compress depending on various factors, fundamentally altering our perception of reality. It is relative to the observer's motion and the strength of the gravitational field. Imagine two identical clocks. One is stationary on Earth, while the other is aboard a spacecraft traveling at an incredibly high speed. One clock remains on Earth, while the other travels at incredibly high speeds through space. The faster the spacecraft moves, the more pronounced the effect on time. According to Einstein, the clock in motion will tick slower than the clock on Earth. This is not just a theoretical concept, but a measurable phenomenon. This phenomenon is known as time dilation. Time dilation means that time itself can expand or contract depending on the relative speed and gravitational forces experienced by an object.
Time dilation has been experimentally verified. Scientists have conducted numerous experiments to test and confirm this aspect of relativity. Atomic clocks flown on jets around the world show a slight time difference compared to clocks that remain stationary. These experiments have consistently demonstrated that moving clocks tick more slowly. While the difference is minuscule at everyday speeds, it becomes more significant as we approach the speed of light. At such high velocities, the effects of time dilation are dramatically amplified. But what does this have to do with time travel? The concept of time dilation opens up fascinating possibilities for traveling through time, at least in one direction. Well, if we could travel at speeds approaching the speed of light, time would slow down significantly for us relative to those on Earth. This means that, while we might experience only a few years of travel, much more time would have passed on Earth. A journey of a few years for us could equate to decades or even centuries back home. This is not just science fiction, but a real consequence of the laws of physics as we understand them. This is forward time travel, and it is theoretically possible within the framework of Einstein's relativity. While we are far from achieving the necessary speeds with current technology, the principles are sound and offer a tantalizing glimpse into the future of human exploration. Traveling to the future, while mind-boggling, seems almost straightforward compared to the complexities of traveling to the past. The idea of moving forward in time is something we can almost grasp, thanks to the theory of relativity. If you travel at speeds close to the speed of light, time would slow down for you relative to someone who remains stationary. This means you could leap into the future by traveling at such high speeds. However, the notion of traveling back in time introduces a whole new set of challenges and paradoxes. Here, we enter the realm of theoretical physics and concepts like wormholes. Wormholes are fascinating because they offer a potential solution to the problem of backward time travel. These hypothetical passages through space-time could connect distant points in both space and time, creating a shortcut that defies our conventional understanding of the universe.
Imagine folding a piece of paper in half. This simple analogy helps us visualize the concept of a wormhole. Now picture a tiny tunnel connecting two distant points on the paper. This tunnel represents a wormhole, a bridge that could theoretically connect two separate locations in space-time. That, in essence, is a wormhole, a hypothetical shortcut through space-time. If such structures exist, they could revolutionize our understanding of the universe and our place within it. If wormholes exist, they could potentially connect different points in time, allowing for backward time travel. This means you could theoretically travel to the past by entering one end of a wormhole and emerging at a different point in time.
Another intriguing avenue for time travel lies in the realm of quantum mechanics. Quantum mechanics is the branch of physics that deals with the behavior of particles on the smallest scales, and it is full of strange and counterintuitive phenomena. The quantum world is full of strange and counterintuitive phenomena. For instance, particles can exist in multiple states simultaneously, a concept known as superposition. Particles can exist in multiple states simultaneously. This means a particle can be in two places at once or spin in two directions at the same time until it is observed. They can even tunnel through seemingly impenetrable barriers. This phenomenon, known as quantum tunneling, allows particles to pass through barriers that would be insurmountable in the classical world.
Some physicists theorize that quantum entanglement, the spooky connection between distant particles, could be harnessed for time travel. Quantum entanglement is a phenomenon where particles become interconnected in such a way that the state of one particle instantly influences the state of another, no matter how far apart they are. Imagine two entangled particles, one sent into the past and the other remaining in the present. This connection could theoretically allow for information to be transmitted across time. Manipulating one particle could potentially affect its entangled counterpart in the past. This idea, while speculative, opens up fascinating possibilities for time travel and communication across time.
However, it's crucial to remember that these concepts are highly speculative. While they are grounded in theoretical physics, we have yet to find concrete evidence that they are possible. We haven't observed wormholes directly, and their existence remains hypothetical. Similarly, while quantum entanglement is a proven phenomenon, using it for time travel is still a concept firmly rooted in science fiction. And manipulating quantum entanglement for time travel remains firmly in the realm of science fiction. As our understanding of the universe continues to grow, who knows what future discoveries might bring? For now, the idea of shortcuts through space and time remains a tantalizing possibility, a testament to the boundless curiosity and imagination of the human mind. Time travel has been a recurring theme in popular culture for over a century. H.G. Wells's groundbreaking novel, published in 1895, laid the groundwork for countless time travel stories to come.
From Back to the Future to Doctor Who and Avengers, Endgame, time travel has been used to explore everything from romantic comedies to epic space operas. These stories often serve as thought experiments, exploring the paradoxes and ethical dilemmas inherent in altering the past or glimpsing the future.
These films and TV shows entertain and spark our imaginations. They encourage us to contemplate the nature of time, free will, and the consequences of our actions. They remind us that the past, present, and future are intricately intertwined.